So now we are into our second module, that is integrated operation management approach, IORM I referred here, and here we will be discussing the approach in this lecture, and in the next lecture we will be developing as a system. Of course, time limit is imposing sort of constraint where we cannot go into the details, but whatever details are provided, probably it will be sufficient for you to for your takeaway and for future learning. So, integrated operational risk, we have been talking about that the holistic operations risk perspective, complex system operational safety consideration must go beyond its predominant or conventional risk model that focuses on postulated potential exposure hazard to public property, economics and occupational members, where the goal is to work towards zero risk or at least minimal risk, acceptable risk. So these were the design objectives, and that based on this only we have had the definition of safety. Okay, this is vital and critical part of the risk evolution. But then our definition is getting wider in terms of what should be considered in the risk, and of course the other side of it is safety. So industrial risk is very important component, though it has only local effect, but it should form the part of the risk matrix. Then security risk should be there, and cyber threats. Cyber, of course, the safety critical systems are normally isolated through firewalls and physical separation through cyber threats, but then this has to form what is the potential for those kind of risk, and like we give estimates of probabilistic risk assessment or safety assessment. For this also risk matrix should be, quantitative risk matrix should be available. And then reliability risk. When we talk about the reliability, we say uninterrupted operation of the plant, and when the interruption occurs, plant goes to the safe mode. Now, this is if our definition of safety extends to public domain, then power failure itself has got some consequences in terms of public domain. It could be in the traffic area, it could be in the hospital, non-availability of power supply, or we can examine any area and we should see what are the risk implications. So that even though plant is safe, and of course when the plant is operating smoothly, and when it enters into transient for shutting down, there can be some component of risk involved. So reliability risk in smooth plant operation, and if an interruption, and this risk component should be analyzed and it should be demonstrated that what are the consequences in public domain. Plant unavailability risk, again the same. So plant reliability and availability, they go hand in hand together. Loss of credibility and reputation risk. These are the spin-off or they are indirect consequences. Financial risk and liability risk. So a holistic view should be taken in whenever we are operating any complex or safety critical or risk critical system actually. So this is just a definition. It has been developed for ORM, and it tries to enhance the scope of the safety, or So how to define the risk for the purpose of safety critical system and it can be defined as the likelihood of undesirable operational event sequences due to random. So random means it covers safety part, and inadvertent, that means it covers the or intended malicious cause. That means deliberate causes. It takes care of the risk aspect, security aspect, leading to failed process and safety measures. So the intermediate consequences is failure of the process and safety measures, having potential for internal or external undesired consequences. Okay. Particularly the ones involving fatalities, mass injuries, adverse impact on environment and property in public domain. So, what we discussed in the previous slide, we are trying to translate it here. So, safety and security we have talked explicitly here, but other intangible things also gets covered. If we look at this definition, the definition caters to the operational ecosystem with due consideration as follows. One is that safety risk and security risk underscores, apart from hardware and software, the human factor also. The history of accident shows that most of the undesirable events have local or internal consequences, while there are few that leads to external consequences also. The above also highlight the severity by comparing internal and external consequences. So, for ORM this definition will follow, and this becomes the basis for our way ahead for this. So, now we have different, so this is integrated statement. I was mentioning how we are trying to integrate. So, these are different component of the risk, technological risk, or type of plant, we can say. Even if you call energy system, what is that energy system? Whether it is environmental risk, accidental risk, in time domain, how it works out, industrial risk, then delivery, or you can say reliability and unavailability risk, and then security risk and liability risk. Technology is related to industry specific hazard. Here it is referred as technology risk. If it is an energy system, there is one thing. If it is a chemical system, there is another thing. Space, aviation, we can see the technology or domain, and then we can develop a system risk matrix over there. Then industrial risk. In fact, it is there for common denominator for all the risk, but then it has to be analyzed in detail, and it can be avoided. And this is, I think, oldest safety domain that has been going on. So delivery or reliability risk involves interruption or loss of availability. As I mentioned, in public domain there could be some consequences, or even plant interruption can be sometimes, so potential has to be seen, like we analyze shutdown and low power risk and all that. So, once plant, in many industry, shut down the plant and it is we are safe. But for some industry, it is there is still there is a very small component of risk that is there, and it should be ensured by estimation, proper scientific procedure. How small is this component? Security risk, relatively new dimension, but it is widely being adopted across, because the socio-economic condition is such that it requires proper attention. And liability risk, any accident brings a tangential or intangential component that might include technological risk, supply chain and all that. So, if I take my technology and I develop an integrated risk statement, then how these components they are showing up there, and that is decided by the weight factor. So how much weightage, it depends on the expert, how much weightage they will give to these factors, and that's how this provides a framework for us to handle and integrate different type of risk components or risk metrics. Because even in a technology, there can be varying type of plants. So for every plant, there will be a different risk matrix. Though broad umbrella remains same, but still at a specific level, it might change. Type of risk and modeling techniques. So technology risk, we have this method, deterministic and probabilistic, like we call more in nuclear domain. These two are the techniques that we use. Of course, the traditional technique is deterministic, and even today it is relevant. PRA actually, in terms of at regulatory end, it complements or supplements to the deterministic method, but when we think of developing a application based on PRA, it is called as risk based technique. Okay. Then security risk assessment. Security risk assessment is a new dimension, but it's another component, cyber security risk. This is becoming more and more predominant, and a systematic document is required, and provision should be implemented to handle the security risk. At the level of power grid, it might involve the power theft. Security risk have the component of insider and outsider threat, and this is something insider threat and outsider threat. This paradigm was not there when we had this safety oriented risk assessment. Here deterministic and PRA are the modeling technique. Here also lot of knowledge, because what kind of provision, barriers, alarm, trips that we provide, they are basically based on deterministic, but what will be their performance, it gets revealed through assessment part, and that is where the test, maintenance and all the programs are required, and the data should be analyzed on periodic basis. Now industrial risk, it is a component, probably the society has seen the longest since ages what kind of precaution we should take, whether it is electrical system, mechanical system, electronic system, it should be water bodies, or any ecosystem, fire and all that. So industrial risk has been playing a very important role, and probably you will see where it got compromised. Newspaper article will show you, and the one observation is that yes, in societal domain a serious look is required to address these issues. Type of risk and modeling techniques. We have loss of reliability and availability. So this from previous slide we are continuing. This component, as I mentioned, it might have its own component, and probably it imposes a risk component from the societal domain. So that note has to be that conscious observation should be there, and it should translate into risk informed or risk conscious operations management. Liability risk, yes, liability risk is it could be insurance related rate, it could be related to some accident, what are the intangible or financial or legal things are, and then at the end of the day it is a reputation. One accident anywhere and it affects it doesn't have a local effect alone, major accident I would say, not but it can have its own repercussions. So that also has to be formulated. Now integrated, what is the framework after having these lessons that we have? So one thing is development of integrated operational management framework is a complex task. Let us admit it that it is a complex task, because first we are dealing a complex engineering system. Second, the reliance on a very complex system, that is human factor, it is there. Though human factor has been doing well, but it is a question of whether we can and of course we also say that that accident don't happen because of one component failure. Because when we talk about especially in PRA, we talk about the cut sets. Cut set means combination of the component, when they fail the accident happens. So that means from that perspective, how accurately the PRA model has been developed, what kind of data we have used. So these are all complex tasks. It requires a lot of mathematics, interpretation, and the most important is domain knowledge. Data and domain knowledge, it is at the core of developing any system. So and sometimes there is a multi-objective function. I mean, if I have risk reduction is my objective, of course I cannot talk without considering into plant operation or its deliverables. So we are at crossroad where a optimum point or operational point we have to look forward to, where both are acceptable mathematically also and at the level of management also. So that is where risk informed approach comes into the picture. Every industry and its type and level of hazard size might have a varying requirements. Okay, these things are known when event occurs. So, one good thing at this point of time when we are having this course is good that reasonable amount of data is there. Suppose in some case data are not there. Now there are experts available and there are technology available like fuzzy analysis. Probabilistic requires data, uncertainty will be wide, so data is not adequate. But then we have a fuzzy logic where expert opinion can be translated into some quantified parameters, and there can be some assumptions that importance factor has been taken into account and all that, but it is better than nothing is available. So, and expert opinion can be taken seriously because it is a domain knowledge that is coming and translating into the mathematical parameters. Keeping in the view the weightage and what weightage? Weightage plays a very important role. So, it should be called a scientific system, should be developed for giving weightages to different type of risk that is there, and that is again a complex task. So, let us agree here that we are dealing in a complex area of modeling and management. Because there may be so many psychological factors, so many physiological factors when we talk about the human performance and its characterization. So, but then let us start with some assumption and try to build a model. So, what are the assumptions when I am talking about developing a model as part of the ORM? I have used the topography of a artificial neural network. It is one of the most used technology in artificial intelligence, third level of that is deep learning. So, let us use the best approach for it, and all the risk factor that are there with the different technology, because ANN allows inclusion of the technology, and so that gets integrated to giving final risk, and then it allows to give weightage also, because weightage is a inherent component of artificial neural network. So, 5 types of, here we have taken 5 types of risk. It could become more complex if we take many more nodes over here, and then we take input and assign weights. This is a input layer, this is a hidden layer, and this is an output layer. It is one of the simplest presentation for this lecture I have chosen, and that is how we have a generic IORM, integrated. I will be using this word IORM, integrated operation risk management system, and here it is a model. So, we have this, and now we know that there are different risks. Okay, one word of caution: normally RT we use for reliability over a period of as a function of time. But and of course failure rate. So, reliability is a function of time, and we have this, but here I thought let me use risk also, and here only it is a local effect that I am telling you. When we do complex calculation, we can use this R with something else, and please do not confuse the messages, do not confuse with reliability. It is the risk as a function of time, and the summation of all the I's and RI's. Individual risk I varies from 1 to n, here it is 5, and then representation of the risk and category can be is for RI. What RI is made of? It is made of one weightage factor assigned to this, which I told you this itself is a very complex factor. Okay, for safety it can be very high, next could be for security, then for other things we have to really use the operator judgment, and then likelihood and consequences. These are the conventional terms for risk that we have over here, and what our minimal cut sets are formed is basically initiating event and unavailability of many events. So, whatever form we use, but here it is likelihood and consequences in pure risk format we have used. So, this is for ith risk. Now, if we have summation of this all into 1, as we see 1 to 5, we will see that the total risk will form summation of I varying from 1 to 5, and then capital RT will be formed. So, okay. So, that is a mathematical connotation to risk. Now, what are the procedural elements, which form part of ORCOM? Often the numeric data are not available to characterize the individual risk elements. Therefore, it is required to use expert opinion. So, for us, using expert opinion is not an option, it is a necessity, because data is not available. And if we have a fuzzy algorithm with us, then we can model it also. Experts will tell whether it is in terms of the language, and they will take, there is insignificant, low, medium, high, very high, like this kind of output, and that can be converted into fuzzy estimates, where the membership function is the rest actually. Okay. Then the procedure to develop the input vector, considering the, so now since I am talking about sort of ANN approach for giving integrated statement of risk, I am talking about this model in ANN language. Identify the risk categories. Here it is 5. So, we got 5 categories. Normalize the risk statement for harmonizing. Sometimes when we are talking about different risk, there are consequences of different risk. So, it requires a normalization, and a normalization could be something like in time domain its impact. It could be the kind of damage it can do instantaneously, the kind of damage it does over a period of time, and what is that time, or so consequences and likelihood also. Suppose if a certain event is having a very low likelihood, so risk will be very low, but then we should be able to connect it to the societal domain also. What kind of society we are operating this system? So, normalization is a way. We do normalization for many parameters, same thing applies here, but here again I will use the term, it is very complex, and complex to the extent that it might become subjective also. Assign the weightage factor to each risk category based on the risk significance inside the, again this also is a very complicated factor, but the issue is one reference model can be developed, and then all the development can we can come around and talk about it, what should be what, and a subject can be developed. Develop a fuzzy model. Okay. Probably I have dealt or discussed fuzzy approach for in risk and reliability. So, you can revisit those areas. And development of transfer function in ANN architecture. What should be the transfer function? There are some activation function in ANN. So, sigmoid is there, then there are a number of which function I should use. I mean, sensitivity will depend on, because ANN itself even today it is like a black box, So, one has to be very clear, only validation is when ANN predicts something and it meets our mind, that is experts mind, this is how it should be, and but then that is a great achievement actually if you does this. This I am sharing you my experience. If you design, if you have data for ANN, then my early 90s experience where people were not accepting ANN as a tool for some serious thing, and today the time has come when we are all talking about ANN. Domain knowledge is very important. If domain knowledge is not represented, now we call feature extraction, data analysis, data modeling. So, those things if it is not there, ANN will not be able to predict. After all, it is a mathematical algorithm actually. Okay. Perform training of ANN employing 80% of the vector. So, whatever data we have, we use 80% data for training, and the another 20% for recall test. That means new pattern has been presented to ANN, and we are trying to see the response. Okay, and that tells us how well we are able to model the procedure. Now, there is even though in this lecture itself I was talking about a risk informed and risk based approach, and the bottom line there is we have considered, if I go by verbatim, risk informed. If we inform something and then we start doing based on that decision certain jobs, but I am giving a twist to this term. I am calling risk conscious till it becomes the part and parcel of risk conscious culture. Information, finally everything is playing out at the level of brain. So, that quotient of risk conscious culture should be seen, and that is why I have a nuclear plant, I have information knowledge. It has to transfer function will occur here. Consciousness, what is the level of consciousness that you have about the tool methods that you design, and how it has translated in operating ecosystem, and that is where risk conscious culture comes into the picture. And when it is striken our conscious level, subconscious level, they will not go into all those things. So then only we have a really closed loop here. Otherwise, this loop is not. My question is, this loop has to be strong, and it should be through conscious culture, which is, this is a transfer function over here. Okay, so and then there are many more. Lot of work have been done in this area. So good thing about this time is we have some metrics, for decision making, like reason one, when the plant core damage frequency. I think my student will know what is CDF. Please remember this word, core damage frequency. It is a direct statement of risk at level 1 PRA. Statement of risk, core damage frequency. That means it will affect the reactor core in an adverse manner. What is the probability? We are not talking, these are all postulations that we are talking about it. So 10 to the minus 5, if it is more than that, this whole reason becomes, no changes can be done if you are operating in this. And then another, this is change in core damage. But absolute value of core damage, so if we have up to 10 to the power minus 5, yes, this but as we go on increasing, it becomes prohibitive. In fact, to me, it becomes prohibitive here also. Point number 1. Point number 2, this is all discussion we are doing at level 1 PRA output, and then reason 1, reason 2, reason 3. Even though we have shown, I have tried to show gray area, but it is seen as a line. But actually, these two boundaries, that is black and white, they do not have a very crisp boundary. There is a fuzziness here also. So evaluation of fuzziness also should be done instead of a point estimate. So what we require? We require uncertainty estimate of change in core damage frequency and absolute value of core damage frequency. Then we can interpret these reasons. So uncertainty considerations, because if we say today as a probabilistic person, anything is available at point estimate, 5 kg pressure, 10 kg pressure, gone are these days, because we used to use large factor of safety. But now we have to make the plants to make it very effective and deliverable also. So there has to be a question on what kind of conservative should be built into the system, and when we do that, uncertainty automatically form part of it actually. So these are the area, and basically they are used. This is a US NRC, I think document 1 something, So that document, it is there. It is part of many IAEA Tech Doc document also, and it is in public domain, of course. This is the metrics. So what we are saying is, we are lucky that we have some decision metrics. Earlier in the deterministic era, this kind of decision metrics were not available. So we had to go by stipulation only. But now even technical specification can be dynamic in the sense that a computerized technical specification, and if you have data background, good background, you can take a chance, you cannot take a chance. Okay, so that translates into enhanced availability of the plant without compromising the safety or increase in risk component. So we have saw the integrated operational risk framework, the ORM model development. We used ANN paradigm, but if somebody can use some other paradigm, that is acceptable. But to me, it looks the weightage factor, activation function, and all, they are very effective. Only thing is, one has to bother about the quality. So role of fuzzy logic has become important if data is not there. And risk informed risk based approach and risk conscious culture, the distinction. So we have discussed what is the difference between integrated information theory. It is, the consciousness is built on information, but then there is a at a brain level, at a microtubule level, how it is getting translated into part of a human existence. That is the question actually here, and that is where we use risk conscious culture. Okay.